The general process of a client requesting and getting an IP address from a DHCP server is DORA, which is an acronym for 4 specific DHCP message types: discover, offer, request, and ACK, short for acknowledge. A client device will broadcast a DHCP discover message at both Layer 2 and Layer 3. The Layer 3 broadcast address is 255, 255, 255, 255. The Layer 2 broadcast address is 12Fs. For the source IP address, the client uses the unspecified address of 0000, quad 0. The client's default gateway, also acting as its relay agent, will need to be pre-configured to know about the DHCP servers in the autonomous system. When this router interface sees the broadcast traffic and inspects the UDP datagram to see a DHCP discover message, the router will replace both the frame and the packet and send the UDP datagram as a unicast message in a new frame and packet to a DHCP server through the normal routing process. The server, when it gets the DHCP discover, which is now a unicast, will check to see the relay agent's IP address, which was added to the DHCP portion of the message. This allows the DHCP server to know which network the client is on and give the client an address accordingly. The gateway will always be on the same network as the client, assuming a subnet mask for all networks of 255, 255, 00, which means the first 2 octets are network octets and the last 2 octets are host octets. If the router's IP address is 10.1.0.99, the DHCP server will give the client an IP address that starts with 10.1. If the router's IP address is 10.2.0.99, the DHCP server will give the client an IP address that starts with 10.2. The DHCP server will also give other pieces of information to the DHCP client, including subnet mask, default gateway IP address, DHCP server addresses, DNS server addresses, and more. The server sends a DHCP offer in a unicast message back to the relay agent, who relays it back to the client. Most dedicated DHCP servers will send this back as a unicast message to the client, with or without a relay agent, even though the client doesn't yet have true possession of the IP address. The DHCP servers we have at home run in that little box that everyone simply calls router. In that box, the DHCP service is not as robust as it is on an enterprise server, and will almost always send traffic from the server back to the client as a broadcast during this process. Then, the client will send a DHCP request message, again with a destination broadcast address and a source IP address of quad 0. As mentioned, the client might actually be reading messages to the unicast address that is still not fully bound to the NIC. However, the client can't send unicast messages since the client doesn't yet officially have the address. So the client has to use the unspecified quad 0 address as the source and a broadcast address as the destination. Once again, the relay agent turns this into a unicast and sends it to the DHCP server. The DHCP server, in turn, will send a DHCP ACK message. After the client gets the DHCP ACK from the relay agent, the client will now be able to start sending unicast messages from this IP address.